Okay, hello students. Today we're looking at 6.6 day 1, solving radical equations. So we've seen a lot of work with simplifying these things. Now we're going to finally be putting it to use for solving for these missing variables. So really all we're looking at today is another step in the series of steps that you guys have been doing for a long time with solving equations. So if you recall, you had one-step equations where you saw things like x plus 2 equals 5, and you would subtract 2 from both sides so that it was balanced out, and you'd have 3. Or you'd end up with multi-step equations with like 2x plus 3 is equal to 11. You're going to subtract the 3 first, left over with the 2x equals 8, and then how do we get that number off of the x that's attached by multiplication? We do the opposite, and we divide. And you would have ended up there with x equals 4 and things like this. And there's a long list of these types of problems, and you had new steps put in through a year or two of time from 7th through pretty much 9th grade. Okay? So what's happening when we're solving these equations now, you have seen something like this before. We may not recall. How do you cancel, quote unquote, cancel a square root? Well, the inverse operation of taking the square root is squaring something. So if you square both sides, it cancels out the square root. So u will now be all by itself, and u will be equal to 36 because 6 squared is 36. So that's kind of the root of, for lack of a better term, of what we're doing today with solving all these things. We're introducing that square root versus squaring for inverse operations into solving our equations. So the square root of w plus 9 equals 5. The number one mistake that we see here is people try to subtract 9 right away. Okay? You can't do that because, like we've talked about, this square root is a grouping symbol. Okay? That square root is a grouping symbol. You can't remove anything out of a grouping symbol by adding or subtracting it. You have to get rid of the grouping symbol. The grouping symbol that's locking it there is the square root. Okay? So this would be just like the case when you guys would have something like 3 times x plus 2 is equal to 7. You can't subtract 2 right away. You have to distribute that 3 across. 3x plus 6 now equals 7. And that was kind of like you unlocking what was inside. So the way that we're going to unlock what's happening with the w plus 9 is we have to use that inverse operation and square both sides first. We can't free up that w plus 9 unless we get rid of the square root. Squaring both sides will do that. So now the w plus 9 is free. We've unlocked it. And that 5 squared evaluated on the right-hand side will be 25. And now you're looking at a two-step equation that you probably saw in 7th grade, or a one-step equation, where all you have left to do is get that 9 out of there, and the inverse of adding is subtracting. You're going to end up with your w equaling 16. Okay? So the first couple problems are pretty simple as far as number of steps. There's not a lot going on once you get that square root taken care of. Now, this situation, once we get problems like this one figured out, we go ahead and make mistakes on problems like this by trying to evaluate it the same way. The first thing people are going to do here is they're going to try to square both sides. Not going to be the first step we're going to do. If you were to square both sides, you would actually have to take this entire piece and multiply it by itself. That's going to end up being a mess. It'll be 4 different multiplication steps. Okay, again, you don't have to worry about this piece until it's all that's left. Okay, so this is like if we had something like 3x plus 2 equals 5. We're not going to worry about that 3x until it's the last thing there. We're going to get everything else away from it first. We're going to subtract 2 from both sides. You're going to end up with 3x equals 3. Now you can worry about that x piece. Now, granted, it's not the exact same situation because there's more than just an x going on, but there's one big grouped piece plus 2 equals 5. we're not going to do anything with the grouped piece until it's all that's left. So the first thing I'm going to do is subtract 2 from both sides. And now I am looking at the square root of 3v minus 9 equals 3. Now we worry about getting that piece unlocked. Now it's the same type of question that we just saw before. Okay? Now you're going to go ahead and you're going to square both sides to get rid of that square root. So you're going to be looking at 3v minus 9 equals whatever 2 squared is, which is going to be 9. And don't forget to do that, by the way. I do see quite often people will have this as 3v minus 9 equals 3. They'll forget to do that 3 squared and end up with a 9 over here on the right. So don't let that slip away from you. Okay? And then we're 2 steps away now. I'm going to add 9 to both sides. This part, after you square it and you've just got like a 2-step or 3-step equation left, that should be big time review. 3v will now equal 18. I'm going to divide both sides by 3. And my v will equal 6. Okay? So looking backwards here, we basically just added 1 extra step each time. This was just a variable with a square root on it. This was a single variable plus a coefficient with a square root on it. This was a binomial with a square root with a coefficient being added at the end. They're all very similar. We're just adding 1 step at a time through these first 3 problems. It's the same process. Okay? Now we've got 2 whole binomials being squared on both sides. There's nothing hanging off either end. We can't take the 11 out of the first one. We can't take the 9 out of the second one. Sometimes you have to square both sides first. Whoops. Got to square both sides first to free everything up. If you've got everything locked in that square root cage, go ahead and square it first. There's nothing we can do because everything is grouped into a square root. So that squaring of both sides is just going to basically erase that root. So now we're looking at a freed up 8x minus 11 equals a freed up 6x plus 9. Okay, now there's no exact one way to do this. You could move a number of things here. What I always like to do is get my variables together on the same side first, and I like to move the smaller one. So then you're dealing with more positive numbers. So I'm going to take this 6x, and I am going to move it. I have to cancel it out of the right side and get it over to that left side with its like term. A lot of people will divide by 6 here because that's what we're used to doing whenever we're moving or finishing something with a variable. You're not solving for x yet. There's no need to divide. You're just picking it up and moving it the same way that we're going to move that 11 or that 9. You're just going to subtract 6x from both sides. So it's gone from the right. Combined with its like term on the left-hand side, 8x minus 6x will be 2x. The minus 11 is still hanging out there, and the 9 is now all alone on the right. Next step, get everything now away from your x, because we want to get that x all alone now on that one side. So now I'm going to move that negative 11, I'm going to add it to both sides. And I've got now a 2x all by itself on the left, equal to what is now 20 on the right. And my final step will be dividing by 2 and getting x equals 10. Last problem here is going to be a word problem, because why not? If a person's eye level is h meters above the sea level, and she can see d kilometers to the horizon, then the equation they give us to represent that is d equals 3.7 times the square root of h. Excuse me, 3.6 times the square root of h. Suppose the person can see 18.99 kilometers to the horizon. So they're giving you that d variable. What is the height of her eye level above the sea level? So they're giving us what we're going to plug in for the d variable. And then just in case we aren't sure quite yet, what is the height? They're asking us for that h. That's what we're going to have to go solve for. So 18.9 will replace d equals 3.6 times the square root of h. Okay, so this is another type of problem we haven't exactly seen yet now with something out front of that square root. Remember, don't do anything to address that variable until it's the last thing left. So you're basically looking at something like this. 18.9 equals 3.6x. What do we do when that is our situation? We have to get that x piece all by itself. So we're going to divide by 3.6 on both sides, right? So that's what we're doing first here. We can't address that group h. We can't address that variable until it's all that's left. So I'm going to divide by 3.6, divide by 3.6, and I'm definitely going to need a calculator quick for that. 18.9 divided by 3.6 is going to give you 5.25. So you end up with 5.25 on the left is equal to now just that square root of h. Now you've got all the way down to that point, and all that's left to do to get h all by itself is to square both sides. So it cancels the square root that's locking in that h, and they know a decimal answer is coming. They want you to round your answer to the nearest 10. Okay? So as soon as you take that 5.25 and square it, you're going to end up with 27.5625, and rounding it to the nearest tenth will be 27.6. The 6 in the hundredths place made that 5 bump up. And that would be your final answer to the nearest 10. And that's all we've got for 6.6 day 1. So just getting into the kind of basic type equations for solving with radicals. And we'll see a little bit more of this carried forward on 6.6 day 2.